Hi students, let's look at this question here, which is on normal distribution. So we are told that a type of metal bolt is manufactured with a nominal radius of 0.8 cm. In fact, the radii of the bolts measured in cm have a distribution of a normal distribution of n, 0.8, and a standard deviation of 0.01. Okay, find the percentage of bolts that have a radius between 0.79 and 0.82. Okay, so this is just a calculator work, so I'm just going to key in calculator. Right, so this is x, so n is 0.8, then we have 0.01 square. So the required probability, so okay, actually just name it as R is easier, radius. So the required probability would be between 0.79 to 0.82. Okay, but they want in percentage form, so we could just multiply by 100 later, not an issue. So just key in calculator here. So here what we have is just go to second distribution, then you just go to normal CDF. Okay, and the key in lower would be 0.79. 0.79 and upper will be 0.82. Okay, so 0.82. Then we're just gonna key in the mean and the variance. The variance is 0.01. Okay, so paste it. So that will give us 0.81859. So they want the percentage. We just change it to percentage. So part 1 done. So metal washers are manufactured to fit the bolt. Okay, to fit on the bolts, right? So the inside the radii of the washer measured in cm have the distribution of this. So this is washer. So I'm going to let W be the radii of the washers. Okay. So this is the washer. What we have is actually the W, which is the inside radius here, right? So say this over here. This is W. So we know that the circumference of the washer would just be 2 pi W, right? So there's that. Right, it's just 2 pi r. So essentially what we want is the circumference here, right? We want just this length here. So what is this length here? So this distribution here is not too bad. We know EC will just be E expectation 2 pi W, which is actually 2 pi EW. Then after which we have variance C, which is actually variance 2 pi W. Then we remember to square the constant in front, right? So this will be 2 pi square variance W. Okay, that's that. So once this is done, you could just key this to C, normal distribution. 2 pi, this will be 2 pi 0.81. Then this is 2 pi square 0.012 square. Okay, so we're going to do that. Then this is 2 pi 0.81. I'm just going to key this calculator. Then 2 pi square 0.012 square. Now they ask you what is the circumference that is exceeded by 5% of the washer. So essentially you need to inverse norm, right? Okay, the idea is basically now you have this distribution here. You want 5% on the right because they say the circumference that only exceeded by 5%. The 5%, this is only exceeded by 5%. So essentially you only want this over here. Okay, so essentially what you want is 5% of it. I'm going to be P. This is a P. We need to find the PCM there. It's actually 5%, so 0.05. So in this case, we can just use GC and just inverse norm. So from here, what we need to do is just inverse norm. Go to second distribution, inverse norm. Okay. Then the area, we could use right, or you can use 0.95 first. You can use right. Just remember to put right here. Okay. Then after that, your center, you just put 2 pi. So 2 pi times 0.81. Then this is 2 pi times 0. So 2 pi 2 pi multiplied by 0.012. Okay, so then that's that. We managed to find our value P. This is this. Okay, so that's that. Okay, so that's it. We round to 3SF. This is the value here. So let's look at part 3. The bolt and the washer are a good fit if the inside radius of a washer is greater than the radius of the bolt, and the inside radius of the washer, which is W, is not more than 0.04 cm greater than the radius of the bolt. Okay, so Meaning to say, you want the washer to be great because the washer is the one that feeds the boat. So let's say this is the washer, okay, as such, right? When the boat is this over here, so you have a boat like that, okay. This is the boat going in. So essentially, you need the inside washer radius to be these radius have to be bigger than this in order for the boat to fit in, right? So in other words, W is greater but not more than so W minus B cannot be more than 0.04. Okay, so essentially that's the idea there. But you have to be W minus R lah, radius of the boat. Okay, so not more, not more than. So you can put at most. It doesn't matter. It's the same thing, right? So this is continuous, so it doesn't matter. Part 3, write it down here. So what we need to do now is W minus R is W is bigger than R. Okay, so just combine them. So you have W minus R bigger than 0. So it's W minus. So hence, the required probability you are talking about find the probability that the washer and the boat is a good fit. So it's a good fit would then be the required probability. You combine both of them together. You need to satisfy both, right? Okay. So on the number line, you have 0 to 0.04. So one is here and here is here. So the probability of getting a good fit is in between here. Okay. So being a good fit will mean that we need from 0 to W minus R at most 0.04. So this case here, I don't think it's hard. We just need to combine this is a linear combination of two normal variables. So W minus, we just quickly do this, W minus R, normally distributed, will just be 0.8, 0. So it's 2 pi. So EW minus ER. Then for the variance, remember to add them. So variance W, okay, a lot of students will make this mistake. Variance W minus R will be variance W plus variance R. Okay, because the minus 1 was being squared. So just add both of them up to get 0.01, 0.01 square plus 2 pi 0.012 square. Just key in calculator for this. Should be able to get the answer. Sorry, not C, choose the wrong. So 0.81. So this is wrong. 0.81. I chose the wrong one. So 0.012. This one, just key in this. Okay. So that's that. Key in calculator, we should be able to get answer. CDF. Then the lower is 0. Upper is 0.44. 0.44. Then you just put the mean and we just remember the mean is 0.01, 0.01. Then the variance you need to square root is square root 0.000. Then take note of the number of zeros you have, 244. Close bracket, that will be the answer. Okay, only just now, so 0.7115. Okay. So for part 4 is just a standardization question, right? So the outside radius of the washer, so the outside radius here, okay, have a normal distribution of mu and sigma, square sigma. So then it's known that 50% of the washer have an outside radius of greater than. So basically P, let's say this is O, and let this be O, greater than 1.25, then this cm, which is 0.15, then this outside radius is 1. So this is PO less than 1.15 is actually 0.25. Okay, so we're gonna just write this down and then try and solve. Just use standardization. I don't think it's an issue there. So I think this is just a normal standardization question. So we're gonna put this as PV, PZ, right? P 1.25 minus mu over sigma is 0.15. Then we have a PZ 1.15 minus mu over sigma is given by 0.25. Okay, so this case here, what we need to do is just inverse norm. So just inverse norm. Remember, this is standard graph. So we have 0.15. This is pointing to the right. So this is right side. 0.15. right side, you get this boundary here. Then do left side, so you do inverse norm. Left side 25%, right? You get this boundary here, negative 0 point. So this will be the boundary on the left. So King calculator will have from GC solving 1 and 2. Okay, so that's how you solve this question here proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.